Here's our first example with comparison test. And I want to note, does this series, the series as n goes from 1 to infinity of 1 over n cubed plus 5 converge or diverge? And I'm looking back at this comparison test, and what you're going to have to do is, you cannot ignore this inequality, whichever way you're going to go, with part 1 or part 2. And so I'm looking at this problem, and I'm thinking this, okay, the degree of the top is what? Is 0. The degree of the top, 1 times n to the 0, and the degree of the bottom is 3. And just like on that problem I started class with today, that let's think about some algebra, what terms are in control here? The 1 on the top and the n cubed on the bottom. That's your series B sub n. So for series B sub n, we're going to let series B sub n equal the series of 1 over n cubed. That's what you're going to pull out your toolbox. Does this series converge or diverge? It converges. How do you know? It's a P series, and P is 3. So this one converges. It is a P series with P equal to 3. So that's greater than 1. So I kind of have a hunch then that the series I'm looking at also converges. But I need to, if I'm going to use a comparison test, I need to show that the inequality also holds. So I got B sub n converging. Now, is A sub n less than or equal to B sub n for all n, or for some n at some point moving forward? Is this true? So A sub n is 1 over n cubed plus 5. Is that less than or equal to 1 over n cubed? Yes. Because what? Denominators get bigger and bigger and bigger, so the fraction's getting smaller and smaller and smaller. So we have all the conditions for the comparison test. So let me write my yes. And if this is not obvious, then you might have to do a little bit of work to show this. But this is obvious in this case. So this is yes. So by the comparison test, series n goes from 1 to infinity of 1 over n cubed plus 5 also converges. So on the test you're going to take on Thursday night, rock solid argument about why something converges or diverges.